Hey everyone, this is Andy Melbuff, and this video is going to be part 3 in our series of exploring the Desmos Graphing Calculator for first-time users, both teachers and students. So what we're going to do is pick up where we left off, and we're going to explore some very specific functions and concepts that we can look at with the Desmos Graphing Calculator. Again, I encourage you to sign in or create a free account if you haven't already, so that any of these screens that you like, that you work with, you can save them. So I'm going to start over in box 1 in my expression list on the left hand side, and I'm going to create a list of numbers. Now in the previous video I used capital X. Here I'm going to use capital L for list, and I create lists with square brackets. So I'm going to make a list starting from -5 to -4, ... to 10, which makes a 16 element list here. There are 16 values in here. And now we're going to explore how we can do some statistical analysis of that, some basic stats things for middle school and high school students. Now, some of the features or functions Desmos recognizes we're going to take a look at here. One of them is the word total. So as I write the word total, I can then put in parentheses total of what list. If I put a capital L in here, we'll get a 40. That means we've added up all of the values in list L, and the total, the sum, is 40. What we can also do is we can manipulate that a little bit, and we could, in fact, I'll just go back to box number 2. I know I have 16 elements in there, so I could divide this by 16, and in a way I can find my average or my mean. I'm going to take it back to just the total. Some other feature keywords that Desmos recognizes, and this is one I use quite a bit: stats. I'm going to create stats for list L, and these give me my minimum and maximum and my 3 quartile values. My first quartile, my second quartile, my third, and the second quartile is, of course, the median there. So this is available for students and teachers to calculate with. Some other features statistically. Besides those values right there in the stats menu, we can also find the variance of L. Here's your variance of L, and this calculates it for you for those teachers that don't want their students calculating it by hand. And we can also do standard deviation. STDEV gets you your sample standard deviation, and I'm going to use the same thing for population, but I put a P after the V, and there's my population standard deviation. So those are some basic stats functions that we can use our graphing calculator to determine for us. We can also explore some certain types of statistical displays available to us in the Desmos Graphing Calculator. In box number 1, I've changed my list from the one I used previously to this one that's showing here. I still have 16 elements in there, but I have a lot of repeats in there. So things we can do here are look at histograms. We just need to type in the word histogram. And as soon as I get the M in, it recognizes histogram, and I can put in parentheses L. And so over here, this histogram will be displayed. Excuse me. I can again hold down on this circle over here to the left of histogram to change colors. There aren't many other options there other than the color change. And this is a frequency histogram. That's what's meant by count here. So we're counting how many 2s we had, how many 3s we had. If we want to see all of the integers there, we can make our step on the x-axis be 1s. So that might be a little clearer for us there. But I can also change this to a relative frequency histogram, which will then show percentages. And this zoom fit feature is really nice because it'll give us a nice viewing window. So a histogram is something we can show from a list, and we can also make a dot plot. We just spell out the word dot plot, again put list L in parentheses, and here we're not seeing it displayed because of the settings I had on my window before. I'm going to go back to my home settings. There's a dot plot. And I'm going to change my histogram back to a frequency histogram, and now that kind of matches with what we see on our dots. If that histogram is in your way, just turn it off with a quick click on the circle in box 2, and here's our dot plot. And again, we can use that zoom fit feature if we wished, and we're good to go. So a third type of display we can show visually for students besides the histogram and the dot plot is the box plot. We just spell it out again like we did the others. So here's our box plot showing in purple, and it is automatically by default offset 1. That means it's 1 above the x-axis. If I want it to sit higher, I can change that to 2 or 3, etc. I can exclude outliers if we think we have them, or not exclude them, totally up to you. There aren't any outliers for this, so that's why it won't change. But that's how we could show a box plot. And again, if I hold down on the circle next to box plot, I can change colors to whatever color I wish to see. So those are 3 displays we can take a look at using the Desmos Graphing Calculator. Another useful feature of the Graphing Calculator is to allow us to do regressions. So what you're seeing on your screen here in box number 1 is a table I already created of x and y values, and you can see them clearly plotted on the right hand side. And I put a note here in box number 2. We're going to use the tilde symbol, which is left of the numeral 1 on your keyboard, but I have to use shift with it. So a typical regression will start with a linear version. Normally, we would type y equals, but if we're doing a regression, we use the tilde key. So I'm going to do shift and then that number to the left of the numeral 1. There's your tilde symbol. And then I'm going to have this be in a certain format. So I could use, if I'm using linear, I could use mx plus b. And I can type that in. Now, problem, I get an error here. Because I chose x and not x sub 1, it's not being recognized. So I need to make sure I use the same variables. So I'm going to use x sub 1 and y sub 1, and then my regression will function. Now we're connecting to x sub 1 and y sub 1 in the table, and you can see the line being graphed. This is the line of best fit, and you can see the parameters for that line of best fit. I can't highlight them both at the same time. So line of best fit would have a slope of 1.8 and a y-intercept of 3.2. Here's your correlation coefficient. And if you wanted to see the residuals plotted, or you wanted students to be able to see those, if I click plot here, watch what happens up in the table. We get a third column up here, and these are the residuals. Anything that's negative means the point falls below the line of best fit. Anything that's positive means it's above the line of best fit. And the further the number is away from 0, the further away it is from the line of best fit. So 3.4 here is the furthest one away. That's when we had a coordinate of 3, 12. That's this point right here. This point is the farthest away from the line of best fit. And the closest one, according to these residuals, would be either 512 or 27, which both are 0.2 away from that line of best fit. And you can see the residuals plotted down here. So the closer they are to the x-axis, the closer they are to being on the line of best fit. We can also explore quadratic regression. So I'm going to keep my same table of values up here, and I've changed in box number 3 my linear regression to a quadratic one. And I put in a times x sub 1 squared plus b times x sub 1 plus c. And you can see here the parameters for a, b, and c come out. And we can plot the residuals again, but I'm going to go ahead and turn the graph on. So here's your, I don't want to say line of best fit, but we would say parabola of best fit for those particular points. And again, we could look at the residuals if we wanted to see those. And that same relationship applies as with linear. The Desmos Graphing Calculator will also evaluate summations for us. So I've started out with a note here in box number 1. We're going to use the word sum to get that summation notation. Let me show you what I'm referring to. If I type the word sum, as soon as I hit the M, I get that nice big sigma that we like to work with. And then I'm prompted to decide where's n going to start. So maybe I want n to start with 1 and go up to 5. And it won't evaluate anything yet because what do you want to take the sum of? So I need to have something over here with the variable n in it. So we could have students start playing around with this. So this is going to add together 5 numbers, starting with 1, 2, 3, 4, and 5, and we're going to add 4 at the end. Keep in mind, there's no parentheses here, so this is an excellent opportunity to show students the difference when we put parentheses in. So I'm going to copy this and paste it in the next line, but I'm going to insert parentheses around the n plus 4, and you'll see we get a different result. So here we're adding 4 to each of our n values before we add them all together. So that summation symbol is kind of convenient and handy. We just type in the word sum. We could have an n value start at 3, go to 7, and we can evaluate something like n squared, and then we get 135 over there. So that's a nice little feature to work with in a graphing calculator. We can also explore the normal curve. This is more high school level, pre-calculus level, possibly calculus, statistics. And looking at the normal curve, we have a certain keyword we're going to type in. Normal distribution with just the dist. Normal here, I'll just type it in there. Normal dist. And then in parentheses, we want to have what the mean is, and we're kind of prompted with this right here. Mean 0, standard deviation 1. That's the sample. This is the standard if I don't put any numbers in there. But maybe I want to have a mean of 10 and a standard deviation of 3. So here's our normal curve with a mean of 10, and we've got a standard deviation of 3. And if I choose to adjust the standard deviation, if I make the standard deviation higher, it's going to flatten out my normal curve a little bit. So you can have some discussions with students about what that impact of the standard deviation is on your normal curve. I'm going to put it back to 3, and I want to show you checking this box right here, the cumulative probability. That's basically going to shade in everything under my normal curve. That's because we're showing the shading for going from negative infinity to infinity. And that area under that curve right now is 1. But we can modify these. Maybe I want to find the area up to a maximum of 10. So basically I'm shading half of this normal curve right here, and this shows right here there's a 50% chance I get that, or that's the area also. I can change my 10 into a 6, and you can see that we're changing those shaded areas right there. I can make my negative infinity start at maybe -2, and now let me go a little higher so it's a little clearer. Maybe I want to go from 1 to 6. That's still not super clear. Maybe I'll go 3 to 6. Here we are between 3 and 6, the area under that curve. So that's normal dist. And if you kind of forget that, no problem. You can go down here to the keyboard under functions. And let's go down under distributions. There's a little help symbol there, but there's your key sequence that you want to use. And you can see some other distributions there. And we'll take a look at another one of those here. Another type of distribution that's pretty popular at the high school level, pre-calculus, calculus level, is a binomial distribution. So we're going to label that kind of the same way we did the normal. So I'm going to put my cursor here in box 2. And in parentheses then, I need my trials and success probability. So maybe I want to try something out with 20 trials, and the default right now is a 50% probability. Now it's interfering over here with my normal curve, so I'm just going to turn off the normal curve. So here's our binomial distribution with 20 trials, success 0.5, but if I change my 0.5 into 0.7, you can see it varies a little bit. And again, I can check this, And this will give me cumulative probability between 0 and 20, which is 100% chance of that happening. But I can modify these numbers. So I can change these numbers to whatever I'd like students to be able to work with, and we get those cumulative probabilities there. And again, that can also be found here in your functions under distributions. There it is right there. The last thing we're going to explore in this video is some calculus functionality, what the graphing calculator can do for the calculus students. Well, if a student were to just type in x squared as an expression, it would be graphed over here as a parabola. But if we wanted to take the derivative of that, Desmos recognizes several key sequences. For example, d divided by dx. Now what we're finding is the first derivative of that parabola. Well, the first derivative of that parabola would be the line 2x, and so here we have graphed 2x. So it will graph derivatives for us, and it will also do integrals for us. So I'm going to go down to box 2. I'm going to turn off my first one, and in box 2 I want to do an integral, and I simply type in the word integral. And it's just int now, apparently. It used to be the whole word. So int gets me that integral symbol. And I can put a 1 down here for my lower bound. I could put a 4 up here for my upper bound. And maybe I want to integrate x squared. Now nothing happens. I get an error here because it's reminding us we need dx at the end. So what we're integrating with respect to what variable. So once I put the dx in here, then it evaluates the integral from 1 to 4 for x squared. So some other things to look at notationally, and you can mix and match and use whatever you're comfortable with. Maybe we have some function notation for students. So I'm going to type in the function y equals, I'll just type in x squared again, like we used before. And another type of notation besides this d over dx that we used up here for derivative is f prime. That's not the prime. So I typed in f prime, that's an apostrophe right there, and you can see in purple that this is the line, that's the first derivative, and this will have the equation 2x. So it will graph and recognize that notation as well. And you can do some interesting exploratory things with your kids, like in box number 3, maybe you want to make f of x somewhat variable. Maybe you put a constant in front of the x squared. Desmos prompts us to add a slider, which I will. And then let's watch how the first derivative changes as a changes. So as a gets bigger, my derivative gets a little bit steeper. As a gets smaller, my derivative gets a smaller slope, and you can see those modifications there changing. So those are some calculus key sequence types of things and displays and functionality you can use with the Desmos Graphing Calculator. Thanks everyone.